What is up, ladies and gentlemen, boys and girls, programmers of all ages? Welcome back to the 24th video in Introduction to HaxeFlixel. So in last week's tutorial, we loaded our new map into our world, tested it out, saw that we could get collisions working. We gave the melee monsters very basic pathfinding. Pretty much all they did was walk into the wall and hope they glided off of it and headed our direction. Now, there are two ways that we can get around this problem. The first would be that we use the HaxeFlixel's built-in pathfinding algorithm, which works, well, I wouldn't say it works pretty well. It's really computational intensive, so it doesn't really work for hordes. Or we could use the heat map pathfinding, and I looked into the heat map pathfinding, and I think the algorithm for it is a bit above introduction level. And if I made a real game that I was planning on selling, I would probably end up using that version of the pathfinding. So, but I just want to show you how you could implement the normal pathfinding for your game if you wanted to. It's pretty easy to set up. HaxeFlixel handles most of it for us. So let's go and get into it. So first things first, we want to open meleemonster.hx. Currently under the AI function, we have this line that says flx velocity.move towards point this, saying that this monster should move to the player's point at the movement speed. Now we just want to cut this line out because we want to move it into a specific function. I want to give us the ability to switch between pathfinding algorithms so that we could still use the basic one, but I still want to show you the other one. So right under our animate function, I want to get a new function called move. This function will pretty much just handle the AI that we just cut out. So if this function is used, then we want to use the basic AI. And also I want to have a getter function for the movement speed. Get movement speed of type float. And then return this dot underscore movement speed. Awesome, that should be it for the melee monsters. Next up is the melee test state.hx. Okay, so first things first, and this is not the way we're going to leave this class. This is just so that I can show you how the pathfinding works. So we say for melee monsters dot for each alive handle melee monster. Cool. So we can go down. Or rather, let's say handle monster movement. That sounds like a better name. So handle monster movement. Cool. So then we scroll down to handle projectiles, projectile wall collision. So right underneath here, we can say private function handle monster movement. It will get a monster of type melee monster. And then the first thing we want to do is get var points equals walls dot find path flx point dot get monster dot x monster dot y. Wait, no, sorry. So we want to get the monster's midpoint, and I'm going by the way they did it in the example on the home page. You could probably use get midpoint, but I specifically want to show you their method just to show you a different way of getting the midpoint. So we say, so the monsters.x value plus the monster plus half the monster width. So divided by 2, and then monster dot y plus monster dot height divided by 2 to get the monster's midpoint. Now the find path function requires 2 points, so the point at where the monster is and the point at where the monster wants to be. So as you can guess, the second point would be the monster's target, or in this case, just the player. So we say player.x plus underscore player dot width divided by 2, and then the player dot y plus the underscore player dot height divided by 2. And then just remember the semicolon. So this will find a path through the tile map. Any tile with any collision flag set is treated as impassable. If no path is discovered, then a null reference is returned. Cool. That's easy enough for us to use. So then we say if points are not null, so if there is a path for the monsters to follow, then we want to say monster dot path dot start, and say we want to use the points array. Yeah, array of FLX points, and we want to get the monster get movement speed so that we know at what speed this is. Now if we try to run this currently, we will find that first of all, what's throwing an error? Do I need to save? Okay, never mind. Sorry. So what we find if we run this function now, and I forgot about it earlier, is that if the monster.path will throw a null reference exception, which I found weird, and it caused a lot of issues debugging, especially since I wasn't feeling well at the time. So the way I fixed it is if we go to melee monster.hx again and scroll all the way up, I think it's in the constructor. Yeah, so at the bottom of the constructor it is this dot path equals new FLX path. So that we at least have a path for the monster, so that it doesn't throw a null reference exception every time. And that should be it. Let's see if we test it now. So lime test hl-debug. I know I can just press F5, but I've gotten so used to typing it out. So I'll be back once this compiles. BRB. Okay, so it has compiled. Now if we go into test, melee map, just want to press F2 so that we can see the frames up here. Now if you see me moving, you can see they're so laggy. My computer is starting to scream at me, and this is running only 6 of the monsters. Let me just, not the collision box, I don't care about that, nor that. I just want to see the thingy here that I have no idea why it's so broken. Now let's see if we can't find any of the zombies. Now it's a bit difficult because remember we only have 6 of them on the screen, so we kind of have to go find them. Damn. And I did not respawn. I think that's a bug from last time. Handle. Oh yeah. Lol. Yeah, this is completely my bad. I forgot to set this in the previous tutorial. Let's just go see player respawn position. So it is player respawn position dot get x and player dot respawn position dot get y. Now let's see what happens if we crank up the amount of monsters to say 20 for instance. So let's try that line test hl-debug command again. I'll be back once it has compiled. Okay, it is compiled. So now if we click on test, that was a mistake. Still need to add the in-game menu so I can go back. So after this, it'll probably be the next thing that I work on. So never mind, it's compiled. Now if we say test, melee map, F2, just so that we can get, it's at 6 frames a second. We're practically at that point where we start counting seconds per frame rather than frames per second. And there isn't much we can do to optimize it. I will show you one way I found to optimize it which worked pretty well. And I'll try to explain to you why I think it is so difficult for the computer to keep up. Now it might just be because of the size of the map that we currently have. But I think every frame we try to scan through all the tiles to find the quickest way to the player, and if we run that 20 times per update loop, it's definitely a bit difficult for the computer to do that, I think. Let's just see if we can find a zombie to show the pathfinding abilities. Come on. And I really am sorry for the slideshow, it's horrible. It's why I ended up not using but I still wanted to show how it would work. And I'm sorry for the dogs barking in the background. Come on. Give me those zombies. Where are they? Ah, here we go. Here's one. So if we go over here, for instance, you can see it navigates around the thing. Let's see if you can also see that this zombie doesn't get stuck behind the wall. So the pathfinding is on point. It works pretty well. Let's see if I can't trap them behind this wall maybe. Because the other one would just be like, okay, so the player's right here. Now this one says, okay, cool, let's go around this to the player. So you can definitely see that the pathfinding works. It works pretty damn well. It's just trying to run that function every frame for like thousands. It's not a good way of handling it. You end up you pretty much end up destroying your frames. So there is one where I found around it, but it also kind of broke the collision detection. So if we say underneath player respawn position, let's add private var leader of type melee monster, private var points, array of FLX point, and then private var pathfinding algo of type int, which for now we'll set to 1 so that we can test out the more pathfinding one we showed now with the FLX one. So just scroll down, we say over here, if the pathfinding algorithm is equal to 1, which it is, we'll set the leader equals to null for now, and the points will also be set to null for now, because currently we don't have any melee characters spawned on the map, and thus we also haven't run the algorithm to find the points yet. Then under here we say if underscore pathfinding algorithm equals 1. We want to run a function called find closest monster. This function will determine which monster is the closest to the player. Then we'll set that monster equal to the leader and thus only generate the path finding algorithm for that leader and have all the other monsters follow the path via the leader. So I pretty much went with the follow the leader type of thing. And also I tried saying pathfinding equals 1 and then flxg.collide leader and underscore walls. So you'll see why I try to do this. Even though we have collision detection for melee monsters and the walls, the pathfinding algorithm kind of like overrides it and just says no, we said follow this path, we don't care if there is a wall in your path, just teleport through the wall. Who cares about collision detection? Which I found pretty funny. So next up is the handle melee, handle monster movements. So first up, we just want to say if pathfinding equals 0. So if it's just the normal basic pathfinding, then monster dot move. So just move the normal way. Else if monster equals leader. So if this monster is the leader, then we say points equals, and we can just copy this part because it's a pain to have to write it all out. We can just delete this. And we say leader.x, leader.width, leader.y, and leader.height. And it's all just player. And then we say if points, so if the points is not null, you can just cut this one, paste it. So if it's underscore points is not null, monster.path.start and underscore points. Cool. So this should be underscore leader. Sorry for the dog barking. I think the mailman is coming today, which means all the dogs in our area are very excited, and they really don't like people coming this close to our yard. So right underneath we have, I'm just gonna pause it. Yeah, sorry about that. Back to where we were. So private function find closest monster. So melee monsters dot for each alive. We want to get the monster of type melee monster. If leader equals null, so if no leader has been chosen yet, we just want to say the first one equals the leader. Else var distance between leader and player equals flx math dot distance between leader and player. So this function just gets the distance between two HaxeFlixel sprite objects. So it's pretty easy. And then we say var distance between monster and player equals HaxeFlixel math dot distance between this monster and the player. So if the distance between monster and player is less than the distance between the leader and the player, the leader is equal to this monster. That way we always find the closest monster, set him as the leader, and everyone else has to follow him. Now we should be able to run this. And I'll even now remember, with 20 monsters we had about 6 frames a second. Now if we ramp it up to 2000 so we can have a proper horde again, we can say line test hl-debug, and I'll be back when this has compiled. Okay, cool. It is back up and running. So we say test, map, F2. Now we can already see we're getting a lot better frames. We're definitely at the 60 FPS cap. We can move properly like we used to be able to. Let me just find a monster before getting... came out of nowhere. How's that fair? But I'm also trying to get the horde so that we can have the entire horde follow us. You guys gonna... here we go. And you can see they do have proper pathfinding. If we go this, they don't just go up to the wall, they go around the wall. So you can see, but you also see that they just say, who cares about collision detection? Let's just go through the walls, like over there. They just go through the walls. And this is so funny, because now they're fighting for who's the leader while slowly moving down. So let's see if we move it up. So we can still get horde movements, but now the horde is moving through the walls. Who cares about collision detection when you have proper pathfinding, proper in quotation marks? And it's a lot better, well, sort of better. And now we're getting down to 20 frames per second, but that's draw calls, I think, is the issue rather than just pathfinding. And it works. Like, it's not bad. We can probably use that in an open world without collision detection. I probably find that a very easy way to do pathfinding. And if you created a horde-based monster game, I would definitely suggest trying the heat map pathfinding algorithm. I looked at it, I went, yeah, this might work, but I'm not trying to publish a game, I'm just making a tutorial on the basics and introduction of HaxeFlixel. I don't see why it's necessary for us to learn it. You probably won't make a horde game, you'll probably make like a platformer game or a shooter game or something basic, like maybe Super Mario Bros, where you don't need pathfinding. You just say that this player keeps moving between these 2 points, and that's it. You don't need much more. So I don't think we're going to touch on it. But at least now you know that there is a way for us to do pathfinding in a bit more cleanly. In any case, that should be it for this week's tutorial. If you enjoyed it, please feel free to drop a like, subscribe, and show your love for the channel. Maybe share it with a friend, get them into game development. Who knows, maybe you group of people could start doing game jams. You'll be a lot braver than me. My last game jam went horribly and has scarred me for life, but it is still fun if you like the creativity of it. In any case, thank you for watching. I hope you enjoy your week. Until next time, goodbye and thank you.